In this video, we are going to focus on writing equations with variables on both sides. So we're going to be given word problems, and we need to write equations and solve them. Let's start by reviewing different ways we can state mathematical operations. List as many synonyms that you can think of for each section below. For add, a word that has to do with add is sum or increase. Increasing means add. Combined, when you combine things. Normally, oftentimes it means add. When you gain, that means you're adding. When you have a total, that normally means adding, or more than also normally means adding. When you see a word problem with the word decrease, take away, a loss, a difference. Difference is like a sum, except it's subtraction. Fewer also means subtraction. Multiplication, the word times or product are big ones. The actually even bigger than those is would be words like each. Sorry. Actually, not just each, but per, and the word of. And you may be thinking, how do we use the word per and of? Like, for example, 5 per hour. That would be multiplying something. Or 5 per gallon, or 5 per something. Or like 5 gifts per 10 customers, or something like that. Or if you said of, what do you think? Like 1/3 of. Normally it's a fraction, 1/3 of 100. Or not 1/3, but like 5% of, why'd I use 5 again? I just like 5. 5% of 90 would be an example of using the words per and of in multiplication. And those are probably the most common. But you might see like twice or triple. Twice, which means times 2, which is times 2. Or that would be like double or triple, which is like times 3. Quadruple, times 4. Division, half, which is specifically just like dividing by 2. Split evenly or equally. Quotient, shared evenly is also division. Shared evenly or shared equally. Equals, the word is, like 1 + 1 is 2. That's 1 + 1 equal sign 2. Same. This is the same as that, or are. Sometimes you'll see the word are, which can be replaced by. These are the same. All right. Now, we're doing something else, which is actually going to be super duper helpful, which is identifying rates. And these are going to help you write equations well. And what is a rate? A rate is just it's a comparison of two related quantities. So to give some examples, we have Jackie runs 9 miles per hour. 9 miles per hour is the rate. It is a comparison of the miles per hour. And look at that, the word per, multiplication. She earned $25 per hour. Again, the rate, 25 per hour, a comparison of money and hour. Ryan earned 4% per month, a comparison of a percent and the month. They saved $75 each week, a comparison of money and weeks. He ate 2 pancakes per minute. So 2 pancakes per minute. 2 pancakes is one quantity. Per minute is the other quantity. There were 5 cookies per person. Again, cookies per person. Comparing cookies and people. 3 people dropped out each day. This one's a little bit tougher to see, but the quantity, it's 3 people dropped out. So the two things being compared is people dropping out, and then each day. day is the other quantity. So days and people dropping out finally. Limes cost $1.99 per pound. So the two things being compared, the money and the pounds. So why are rates important? Well, rates can often be found in word problems and will usually be multiplied by the variable. Variable. So if you kind of identify the rate, normally it will be multiplied with a variable. Will this be the case all the time? No, but oftentimes it will be. So let's do some quick exercises to see if we can identify rates from these sentences below. Write R in the boxes that are rates. So which one of these things are rates? Gabby earned $10. Is that a rate? Is it comparing two different things? No, it just says she earned $10. So no, that is not. How about the fare charges $4 per ticket? Oh, $4 per ticket. That's a rate. Now, you may have noticed that the word per or each, per again, out of each day, per or of are words that will tell you that it's a rate. No, per, each, every. The car drives 65 miles per hour. Look at that, 65 miles per hour. You're comparing miles and hours. That is a rate. Jimmy got a $100 tip at work. A $100 tip for, it just says a $100 tip at work. So no, that is not a rate. John walked a total of 10 miles. Is that a rate? 10 miles? What are we comparing? Miles and what? Nothing. So that's not a rate. Rachel earns $25 an hour. What are the two things being compared? The money, hour. Earns $25 an hour or $25 per hour. This is also a rate. Ron decorates 6 cupcakes per minute, every minute. So that's cupcakes and minutes. That is a rate. Erica paid $2 for her outfit. Is it saying it's $22 for each outfit or every outfit? No, this is just saying that she paid $22 once. A rate is normally something that happens multiple times or something that's consistent. So if you're going 5 miles per hour, you're going 5 miles every hour. Or if something costs $10 per item, it's $10 for every item, not just $22 period, because you don't know how much everything else costs. If it was $22 per outfit or for every outfit, that would make it a rate. The company hires 12 new people each year. Are we comparing two things? It's 12 new people. And then each year, yeah, that is a rate. Janet drinks 1 glass of orange juice each day. Yes, that is a rate. 1 glass of orange juice is being compared to the number of days. Andre gets 5,000 new views on his video every week. Is that a rate? Yes, it's new views each week. So that is a rate. The studio has 8 million followers. Is that a rate? No, it's not going up, or it doesn't say anything about whether that's going up or going down. So that is not a rate. So normally rates can convey some kind of change in the numbers, like an increase or a decrease, but like the studio has 8 million followers, it doesn't tell you whether that is growing or shrinking. Whereas like $4 per ticket, oh, the more tickets you buy, the more it costs. 65 miles per hour, oh, 65 miles every hour it changes. So here are your rates. Like this one and this one right here, this one right here, this, and that. Those are all rates. Doesn't form any kind of picture. It's just thought I'd highlight it. Okay, so let's use the keywords to figure out these word problems. Remember, these are equations with variables on both sides, so we are comparing two different things. So let's read the first one. Celebrity A has 400 followers on social media and is gaining 75 followers each day. Celebrity B has 1,000 followers on social media but is losing 25 followers a day. How many days will it take for them to have the same number of followers? So one has fewer followers, like Celebrity A has like 400, and Celebrity B has like 1,000, so like more. But what's happening to B's numbers? B's numbers are like going down, and A's numbers are gradually growing. So what's going to end up happening? At some point, they're going to meet, and they're going to have the same number of followers. So when is that going to happen? Here's how we set it up. Well, let's highlight. This is Celebrity A. Has 400 followers on social media and is gaining 75 followers each day. Celebrity B has 1,000, but is losing 25 followers a day. Those are the two things we're going to set equal to each other. So two things set equal to each other. Let's look at celebrity A. Well, they start off with 400 followers, and they gain 75 followers each day. That is our rate. So our rate is going to be $75, 75 followers times the number of days, and that's going to give us how many days? But they also started off with 400. Some of you may be thinking, like, can I have done 400 plus 75 each day? Yes, you could have. Same thing. On the flip side, we have celebrity B, who has 1,000 followers and is losing 25 followers a day. So they have 1,000 followers, but they're losing 25 per day. So 25 was my rate, which means you're going to be multiplying it by the variable. So 1,000 minus 25x. Now we solve. All right, how do we solve this guy? We are going to combine our variables first. So I can either subtract the 75 from both sides or add 25 to both sides. I would rather add 25 to both sides. 25x plus 25x. That gets me 100x. Now I need to, I could bring down the 400 and then, let's go ahead and do that. Bring down the 400, bring down the 1,000. Now, how do I get these, how do I solve this? Well, I need to get the 100 back by itself, so isolate it by getting rid of the plus 400 by subtracting 400. And 100x, that cancels, sorry, 100x equals 600. And how do I solve it? Divide by 100, and x is going to equal 6. So after 6 days, they will have the same number of followers. Let's try 3. Ben and his friends are going to play putt-putt. At one location, they can pay $2 for their rentals plus $7.50 per game. At the another location, it would cost $8 for rentals plus $6 per game. How many games would they have to play in order for either location to cost the same amount? So one location is cheaper for rentals, but more expensive for games. The other one is more expensive for rentals, but cheaper per game. So how many games before they cost the same? Let's highlight the two. One location, $2 for rentals plus $7.50 per game. Oh, look at that, $7.50 per game. That is going to be our rate. For our other one, another location, it would cost $8 for rentals plus $6 per game. And there's our other rate, $8, sorry, not $8, $6 per game. Okay, so let's set up the first one, the first side. First location says $2, so I could write 2.00, but what's the point? I'm just going to write 2 plus $7.50 per game. The other one is $8 flat plus $6 per game, so plus $6 times the number of games. Oh, whoops, I forgot to write the times the number of games. So remember, rate, you multiply that with the variable. All right, now we have our equation. Let's solve it. Let's get the x's all on one side, the variables on one side. I have 750x plus 750x or plus 6x. Do I want to subtract 750 or subtract 6? I would rather subtract the smaller number, minus 6x. Minus 6x. 750 minus 6 is 150x. On the other side, on the same side, I have to bring down the 2 and the 8, but I know that I have to get rid of this 2, and it is a positive 2, so subtract that 2. And 8 divided by, minus 2 is 6. Now divide each side by 150 or 1.5. 6 divided by 1.5, let's see, that is, off the top of my head, why am I having the hardest time? I am having the hardest time. I believe that is 1, 2, 3, 4. I believe that's 4 off the top of my head. Yeah, that is 4. So after 4 games, the cost is going to be the same for both places. All right, let's try number 4. Haley has $155 in savings, and her brother Hank has $230 in savings. Haley is saving $10 each week, and her brother is spending $15 each week. After how many weeks will their savings accounts have the same amount of money in them? So she has less in her account. He has more. She's saving money, so her money keeps going up. He's spending money, so his money keeps going down. How much will they have the same? So at what point will they have the same amount? So let's look at Haley. He has $155 in savings, and her brother has $230. Okay. So one already, is going to be $155. The other is going to be $230, and that is not a rate. Let's go back to the rates. Haley is saving $10 each week, so 10 each week is a rate. So it's plus $10 per week, which means I multiply by the variable. And her brother is spending $15 each week, so our rate is $15 each week. So it's minus 15x. All right, let's solve this. Get the variables on one side. I could either subtract 10x or add 15x. I'm going to add 15x. I'd rather do that. That cancels. I'm left with 25x. And I know I have to get rid of the 155, so I'm going to, and it's being added, so I need to subtract it. 230 minus 155. That is 75. Divide by 25. X equals 3. There it is. After 3 days, they will have the same amount of money. And then he's going to keep losing more, and she's going to keep gaining more. Let's do the next one. We got 3 more. Isabel takes the bus to work. The bus ride to work costs her $2.50 each time. She could buy a bus pass for a one-time fee of $15 and would then only pay $1 each time to ride the bus. How many times would she have to take the bus in order for the cost to be the same? Let's highlight. She takes a bus to work. That's fine. The bus to work costs her $2.50 each time. All right. Ride to work costs $250 each time. Is that a rate? It is $2.50 per each time. She could buy a bus pass for a one-time fee of $15 and then would only pay $1 each. So you're comparing with the bus pass and without the bus pass. So bus pass for a one-time fee of $15 and would then only pay $1 for each ride. So our two things comparing. We have 250x, which is how much it costs to ride the bus. And then that's $2.50 each time. And then this says $15 and $1 for each time you ride the bus. That is our rate. So we have 15 plus $1 for each ride, so that's 1x. All right, let's go ahead and solve this. I could subtract 250x or subtract 1x. I'm going to subtract 1x, or just x. That cancels. I'm left with 150x, or 1.5x, equals 15. Now, divide both sides by 150, or 1.5, and you end up with x equaling 10, I believe. Divided by 1.5, that is 10, yeah. 2 more problems. Oh, these are the more kind of stranger word problems where it's not really a story. 2 more than 16 times a number is the same as 21 less than the product of -7 and the number. The same as. Remember, the same as means equals. So this first portion, 2 more than 16 times a number, is going to be equal to 21 less than the product of 7 and a number. So now we have to write this out. What is our first side? 2 more than 16 times the number. Well, 16 times the number is 16x. 2 more than that is plus 2. On the other side, we have 21 less than the product of -7 and a number. So product of -7 and a number, that's -7 times a number, times x. 21 less than that would be subtracting 21 from that. All right, let's solve. Get our x's on one side. Do I want to subtract 16 from both sides or add 7x to both sides? I will choose to add 7x to both sides. 21, I believe that is 25. No, 25. 23. 16 plus 7 is 23. 23x. And now I want to get rid of this plus 2, so I subtract 2 from both sides. That'll cancel, which means I subtract 2 from this side. And negative 21 and minus 2, that makes a bigger negative. That's negative 23. And look at that. Divide both sides by 23. That cancels. X is going to, that's not, negative 23 divided by 23 is negative 1. X equaling negative 1. And finally, last one, decreasing negative 5 times a number by 18 is equal to. So is equal to, that's going to be our middle section. So our two things are decreasing negative 5 times a number. So negative 5 times a number. So you got negative 5 times the number by 18. And then on the other side, you are decreasing 9 times the number by 25. Very confusing, I know. Decreasing negative 5 times a number. And so negative 5 times a number is going to be one thing. And you're decreasing it by 18. So subtract 18. Is going to be equal to decreasing 9 times the number. So 9 times the number. And decreasing it by 25. All right, let's solve this. I can choose to add 5x to both sides or subtract 9x. I will choose to add 5x because I find adding is easier and I don't want negative numbers. That's going to get me 14x. And then now I need to get rid of everything else on this side. So there's still a minus 25. I'm going to get rid of it by adding 25 to both sides. That'll cancel. Negative 18 plus 25, I'm going to subtract and take the sign of the bigger number. So the bigger number is positive, and 25 minus 18 is 7. So positive 7 is our answer, or is what happens when you have negative 18 plus 25. All right, now I have 7 equals 14x. Divide by 14. The answer is not 2. X equals 7 over 14, which is the same as 1/2. And that's it. That's how you write equations, write equations with variables on both sides from word problems. Go ahead and try some on your own. Good luck.